Hello everyone. In today's video, we will discuss the different special cases for elastic collision in 1D. We have already derived the formulas for the velocities of the bodies after collision, elastic collision in 1D. So we will start from those formulas and we'll do different cases. So let's write the formula for the velocity after collision. So let's first write V1. Difference of masses upon sum of masses. This is U1 plus 2m2 U2 upon sum of masses. Similarly, for second body, this will be difference of masses upon sum of masses into right. So now the first case is if two equal masses collide. Right. So that means m1 is equal to m2 is equal to m. So let's put the values. Therefore, v1 is equal to m minus m upon m plus m u1 plus 2m u2 upon m plus m. So this gives me 0 and this gives me 2m upon 2m u2. So this gives me u2. Right. Similarly, v2 can be written as m minus m upon m plus m. This is u2 plus 2m u1 upon m plus m. This again gives me 2m upon 2m u1 is equal to u1. If you look at this, first mass was moving with u1 velocity, second mass was moving with u2 velocity, right? Now the first mass is moving with u2 velocity and the second mass is moving with u1 velocity, right? So that means their velocities are interchanged. It has taken its velocity and the second one has taken the first velocity. So the result is velocities are interchanged. What if the second body is at rest and both are equal masses? Obviously, the first will come to at rest and the second one will move with the velocity of the second. So, two equal masses with second mass at rest, or in other words you can say that a mass m collides with equal mass at rest or stationary, right? So how will you write? v1 is equal to m minus m upon m plus m into u1, right? Plus, let me mention it here, that here m1 is equal to m2 is equal to m and u2 is 0. So this will be 2m upon m plus m into 0. So this gives me 0. First one will be stationary and v2 is equal to m minus m upon u2 is stationary, so this is 0 plus 2m1 u1, sorry, 2m u1 upon m plus m. So this gives me u1. So again, so if it strikes, equal masses strike with the second one at rest, So first we moves with velocity of, first becomes stationary and second moves with the velocity of first. Therefore again velocities interchanged, right? So these are first two cases. Let's take the third case. Third case is if a heavy body collides with a light stationary body. So that means this is m1 and this is m2. u2 is 0, it is moving with velocity u1. So what will happen? That means find v1 and v2. So what will the formula of v1? v1 is difference of masses upon sum of masses into u1 plus 2 and 2 u2 upon m1 plus m2. Let's put the values. So if m1 is very greater than m2, heavy is colliding, so m1 is very greater than m2 and u2 is 0, therefore m2 is neglected. So how to solve this? In both numerator and denominator m2 will be neglected. So what will I write, beta? m1 upon m1 into u1 plus 2 m2. In the numerator I can't neglect it, but the velocity of second particle is 0. So this is m1. So this will be 0. So v1 is equal to u1. Right? So let's find v2. This will be difference of masses upon sum of masses into u2 plus 2 m1 u1 upon m1 plus m2. Let's again, in this case also we have to neglect m2. So m2 I am neglecting. So I am getting minus m1 upon m1 into 0 plus 2 m1 u1 upon m1. So this is giving me twice of u1. So what does it indicate? It indicates that if a heavy body collides with a very light stationary body, then the heavy body moves with the same velocity, right? But the lighter body moves with the double velocity of the heavy body. So you can say that heavy moves with same velocity, no change now. u1 and v1 are same, and lighter, that means v2, moves with double velocity. Very important result. And now we can take the fourth case. Fourth case is what? That if a light body collides with a heavy stationary body. So that means a light body collides with a heavy. This is M1, this is U1, this is M2, and this is stationary, right? So let's put the values again. So V1 is equal to, now here what is there? M2 is very greater than M1. Light is colliding with a heavy body. And U2 is 0. So what will be the case? This is very interesting. So V1 is, here what will we do? We will neglect M1 because M1 is very less. So M1 I am neglecting. So this is minus M2 upon M2 into U1 plus 2 M2. U2 is 0 upon M2. So this gives me minus U1, right? And let's find V2. Let's see what happens to V2. Logic you know, but with formula this will be M2. M1 is neglected, so M2 upon M2 into U2 is 0 plus 2 M1 U1 upon M2, right? Now look at this. This is an important thing here. This is 0 plus. M2 is very greater than M1. So if we divide the very high, a small quantity by very high quantity, then it will be nearly 0. So you can say that V2 is nearly 0. So that means there will be no effect on the heavy body, but the light body will rebound. So it rebounds with same speed. Okay, and heavy body remains at rest. So these were the important cases of elastic collision in 1D. So that's all for now. Have a nice day.